We're really proud to say that we use the DJI M600 extensively. I mean, almost entirely for all of our UAV stuff. It's a great platform. And I want to start off by showing you this my whole presentation. I'm just going to bore you to death with bullets. Lots of bullets. Okay, here's why we use the LiDAR stuff. Penetrates the vegetation. Most of the world is vegetated. As a surveyor, I don't know if you can see, I almost kind of have a black eye this morning. Our hotel room I'm staying in is one of the handicapped rooms, and I almost became handicapped at 5 o'clock in the morning. I got up to use the restroom, couldn't find the light switches because they're all in different places because it's the handicapped room. Walked right into the doorknob thing and nearly knocked me out. As a surveyor, I can tell you, you almost get a black eye a lot of time as a surveyor. A, because you're walking on the neighbor's property, and you're usually doing a survey because they hate the other neighbor's guts, okay? Always a good way to start the job. Or you're doing a survey, you're on an ATV, or you're cutting brush, and the limbs are whacking you, hitting you in the eye, or you get attacked by the neighbor's llama that happens to be in the field. It happens, okay? It sounds great until you're the one standing underneath or sitting underneath the llama, which is a big, vicious animal, I'll tell you that right now. Lots of ways you can get a black eye. Anyhow, what we try to do with our system is avoid getting a black eye. If you got the irate neighbor, you start a quarter mile down the road so he doesn't know you're coming. Okay, just a lot of little things, a lot of advantages to the UAV LiDAR. Most of the stuff we do is for construction. As a surveyor, we're out there surveying before the thing is scraped to the dirt. We're out there as a surveyor fighting the ticks, fighting the chiggers, fighting the briars, fighting the fences that we don't see that are there, all the nasties. We get done doing our first preliminary survey, which takes a couple weeks. Let's say a 40-acre wooded lot will take you 40 hours for the survey crew to survey. We can do it in 10 minutes with a UAV. First thing a construction crew does, comes through with the dozers, wipes it out, all the brush is gone, everything. Now we can survey it way easier. But that's not what happens when we're out there doing our job initially. The advantage of using LiDAR is that we penetrate that vegetation because nobody builds buildings on top of grass. Nobody builds a bridge on top of the grass. They all are on top of the trees. And actually, as somebody pointed out to me, one of the VFX companies, nobody has the dinosaurs in Jurassic Park running on top of the grass. They sink into the grass, okay? So even the special effects, getting the ground is important. So I just wanted to go over some of the advantages. LiDAR is 3D in nature, like I said. It's more immediate because it's actually giving, like a total station, it's giving a measurement distance and back. With the imagery, doesn't do that. Another advantage is that LiDAR, hey, we can find a water line. This was back in the late 90s, it was not really well known about the LiDAR and how one of the main advantages, like doing shoreline mapping, photogrammetry, it's kind of tough. You can't tell where the water starts and the beach actually begins because that shallow little bit. But with LiDAR, it was really easy. You have no returns. Once there's water, done. That's the water line. No ambiguity. So that's a really good benefit. We don't require a gimbal when we use LiDAR usually because it's 360 spinning, most of them. Not all of them. LiDAR works in any lighting. Actually, it likes dark actually better than it likes daylight. A lot of times the sunlight affects returns and you get noise as a result of it. So working in the daylight actually can be worse. I like these good reasons at the end here. The contract requires LiDAR because sometimes the contracts do require LiDAR. Your boss thinks it's there. The neighbors have it. Actually, the neighbors one is a good point. It's one of my favorites. I sell a lot of systems. I sell one into, I don't know, pick a town, Louisville. I sell a system into Louisville. All of a sudden, I sell 6 systems into Louisville because Jones have it and all the other guys have got to have it. Okay, good reason for buying a LiDAR unit. Keep it up. Anyhow, so the last 2 reasons is the best one. We need you to buy them. Anyhow, so that's the end of the bullets. So our favorite system here is the DJI M600. With the M600, with our scanner on it, depending on the configuration of the scanners and INS, we get between 18 and 23 minutes of flight time with 30% of the battery remaining. And that's with the X5 camera mounted on it. We get 30 minutes just with a system like this. We can easily get 30 minutes. This guy weighs like 1.5 kilograms, fully up. So we use a variety of scanners from Velodyne, from Quanergy, from Regal, a new one from Septon, and the last 2 are way too big to put on UAVs, the ZNF scanners and the Faro, but we use those for cars. But actually, we have had the Faro on airborne platforms before and on a UAV. It works. but it's heavy, it's kind of clumsy, it's kind of scary, because the scanner itself is 4.5 kilograms plus the adapter. You end up getting 6, 7 kilograms. Yeah, just a little bit nerve-wracking. Then we use a variety of INSs, pretty much any INS from Novatel, any INS from Planix, the Vector Nav systems, super light, very good IMUs, Inertial Labs, OxTS, XBlue. Not all of them are UAV compatible. XBlue, for instance, doesn't make anything small. They're from France. They're all big. They're very good for marine. But that's this is like the workhorse system for us, for UAV, for LiDAR right now. Even though we do lots of different things, lots of different scanners. So I just want to show you a really quick project. We did this just recently in the southeast. So it was roughly 120 acres. Can you see that okay? Some of it's wooded, some of it's not. Ran alongside an interstate. It took 2 flights of 15 minutes using the Velodyne 32 and the STIM 300 from Novatel INS. And you see, we actually, the M600 actually had problems when we took off from here and flew down here. It lost connection, came back. We had it come back, land it, and took off again. So, happens. No reason to freak out. That's why we have certification and training and lots of practice. But 120 acres, and you see that southern part there was heavily wooded. Okay. So here is what the data looked like. It's just a single pass of the LiDAR looking down at it. It's hard to see it as the LiDAR without it actually moving to get an appreciation for what it really looks like. And then there's that cross section of that same data using a QT modeler. So you see there's lots of points on the trees and lots of points on the ground. Okay, and this is full leaf on in the southeast. Okay, so it's about as green as it gets for us. And the little gaps down there, you won't know it until I show it to you later, if I can actually show it to you. Those are actually little streams. Okay, so that's why there's no returns down there. And just another view, the upper right is like looking down on just a section of it. And I tried to show, and the lighting doesn't let us see it very good here, tried to show that you can really see like there's a whole bunch of points in here on the ground, and then here's all the trees. Okay, a lot of points. But again, this is 32 lasers in a 41-degree field of view. And the Velodyne has dual return, but we actually don't use it. So here is part of the finished product. This is in that super duper heavily wooded area. And you can see, well, I can almost see it here. The lighting doesn't let me see it. But you can see there's little formations in there. There's terracing in here that if I was to go out there and survey it by hand, not with GPS, because you couldn't do it with GPS, but with a total station, you'd be traipsing through the woods, and as a surveyor, we look for the break points, what we think where the break points are. We look for the ridges. But you would never even see these ridges in this woods. And so we would go through and collect a model. It would be fitting to the ground fairly well, but we would never see the terracing. And this terracing is really evident when you look at the classified point model. And the classified point model, just so you don't know, is where we throw away all of the vegetation and work with just the ground data. So people always say, hey, that was great, that worked in the southeast, but we don't live in the southeast. Can you penetrate the vegetation in our area? Okay, well, so what we did was we went to Guatemala, and you can see that that's the trajectory right there. And you can see that there's lots of cities. This radius here is like a 60-mile radius. This is really a built-up area. There's nobody living there except for the howling monkeys and tarantulas and the jaguars and all the nice little things you get out there. Very interesting. It's deep jungle. It's about as much jungle as you get jungle. Guatemalan jungle. And this pyramid, the La Danta pyramid, is what we're down there scanning for a TV show. For archaeologists, actually happens to be the lead archaeologist on the movie Apocalypto. But the only spot to land was they cleared off a spot for the helicopter to land up in the upper right corner there, and you had to walk 6 miles to the pyramid, and they'd been excavating this pyramid a little bit. We had to fly this manually because there's no way to set it up. I want to show you, there we go, just really quick speed here. You can see everything is green. We were going to take the phase 1 camera with us down there to get some really good aerial imaging shots. And once we got there, we realized that that wouldn't work. It looks like the top of trees everywhere you go. So the camera just wouldn't cut it. So here is, man, you can barely see that. That's the top of the pyramid. And all these are silhouettes of the people. They're moving around. Silhouettes of the people, top of the pyramid with people standing on, is packed with people standing up there, and there is the one tree. And then that's the top view looking down in this area, and you can see the tree, and this is where they had already excavated some of the surface. And so here is, after we started ripping away all the vegetation, this is a height colorized view of the pyramid from the top down, and then from the side view. So all the trees are gone. Now, there are some things that we cannot penetrate. We cannot penetrate the banana plantation, the super duper thick leaves. We cannot penetrate a full-grown soybean field, a full-grown wheat field. It's just a solid green mass. We can't penetrate kudzu. But in general, we can get through vegetation as well as anybody can. Okay, so just to wrap it up, I want to show you the two new systems. So using the DJI M200 or 210 series, we can take this guy, and right there we got it mounted backwards, but we're going to turn him around. So with its payload capacity of using the TD55 batteries, you have 1.6 kilograms of payload, and we can put either the puck or the puck light on there and still have just enough room to make it. It's obviously not a competitor to the M600 in the sense that you look at the size of the motors of the M600 versus the M200, you got motors that big versus about that big. But I would dare to say if you go to the Ladanta Pyramid with the M600 and you had the choice of using the M200, you're going to go for the M200. You're only going to do a couple flights. It weighs a lot less, much smaller, and it does the job. So the M200 with any of these light systems, you can do jobs real quick. That job I showed you at the beginning was 2 flights of 15 minutes. You could do the same thing with this. I don't know if you could, you had to use the puck light though to get the time. This system today is going to be the tool that used to be the thing that was GPS for yesterday for the surveyors. This system is going to be that same thing. If I can scan a 40-acre tract in 10 to 11 minutes that's heavily vegetated with a stream running through, we can do bare earth classification on it and have the bare earth surface ready to go in an afternoon, the whole project from start to finish, that would take a full week for a survey crew, it's worth it. And then this is the new scanner. It's brand new. It's in our booth. We're in the far end of the hall. If you're able to find this room, you're able to find our booth. This guy will weigh under 600 grams. It's small. It has dual return also. The key thing is it's 2.5 centimeter resolution with 200 meter range. 200 meter range is extremely important because it lets us fly up to 122 meter, 400 foot height in the US. So that's really important. With the Velodynes, we can only fly 70 meters max. We like to fly 45, 50, 55 meters. But with this new Septon, we'll be able to fly at the ceiling and actually put it on a helicopter or something else, even fly higher. It's really small, really light, and it's built for UAVs. It's got a laser going forward and one going back, plus or minus 9 degrees, 60-degree side view, field of view, all down looking, so all the points it's collecting are all looking at the target area. They're not spinning around in the air. It's fast enough, it's got the accuracy, it's really small, very affordable, and it lets us fit on the M200, so we're really excited about it. That's the end of my presentation.